2.8 what? Liters.
8 liters.
Part 3. What is part 3 asking? How many liters of water is in the tank after 8 minutes? By the way, let's do a little recall. What was the initial volume of water in the tank?
67.
67?
Sorry, 6.7.
Zero was empty.
0? What happened to 0? What is the initial volume of water in the tank?
6.7.
Because it was V and we had V is equal to 0.
V is equal to 0? I heard the correct answer.
0.
I heard the correct answer. So keep that thought, the person that said the correct answer. But I'm hearing somebody saying V is equal to 0. I'm not too sure why the person is saying that. So I want to address that.
So we were saying in the beginning, we said the initial volume of water in the tank for question 1 is 0.
I never said the initial volume of water in the tank is 0.
T is equal to 0.
Look at there. T
The
is equal to 0.
initial implies the time.
The
Simply time.
Yeah, the time.
Okay, time is equal to 0.
And here it is
But the
written
the initial volume is 6.7 liters.
Yes, exactly. So the initial volume is 6. When the whole situation started, how much water was in the tank? 6.7. All right? Agreed? Yes or no?
Yes.
Hello? Right.
Yes, we work it out.
Right. So when everything started, the tank had 6.7 liters of water. Then probably a hose come and start to pour water in it. And the volume increasing, isn't that so? At what rate?
2.8 liters.
Just 2.8? A rate is not one number. At what rate?
At 2.8 liters
every minute.
Exactly.
Per minute.
Right. You need to speak the language, you check. At the rate is 2.8 every minute. So every minute, 2.8. Okay? Half a minute would be 1.4, right? And so forth. So now, after some time going to pass, the volume going to reach 8 minutes going to pass, isn't that so? According to part 3, 8 minutes going to pass. Okay.
1 minute at every 6.7, at every 2.8.
Right. Every 1 minute, 2.8 increase. So after 8 minutes, how much water will be in the tank? That's what part 3 is asking. How much water will be in the tank?
Multiply that, I get 22.4 liters.
All right. So let's go through the working because I put some explanation there. You don't have to lay it out like that, but just for explanation purposes. 8 minutes implies what?
So you substitute T with 8.
Yes, but let's take our time. 8 minutes implies what? T is equal to?
An increase in time and an increase in...
8 minutes implies what? Please look at the screen.
T is equal to 8.
8 minutes implies that T is equal to 8. Hence, what are we to substitute?
Substitute
You have to substitute
T is equal to 8 in the place of time and evaluate for V, which of course, from what I am hearing, you all did that already. All right, but I'm just, following with the template I make. So, but I'm very sure you all put a 2.8 and you substitute it now in the place of T, isn't that so? You multiply and you add 6.7. What did you all get for V?
29 point.
29.1.
Yes, sir.
Please verify the orders. Bear in mind, I'm not calculating this. So therefore, the volume of water in the tank after 8 minutes is 29.1 liters. Agreed? Any questions? Let's go to part 4.
No, sir.
Right. The maximum volume of your tank is 50 liters. How long will it take to fill the tank? The tank fulling up, remember.
I can answer a question, please.
Sure.
Okay, so if we value of V here, why are we adding the y-intercept here for the the liters in there?
I don't understand. What you
I
talking
do.
about?
Why
Part
didn't?
3?
Uh-huh.
Well, because we started with 6.7, you know.
Okay. All right.
Remember the tank have
Yeah, that's true.
6.7
Okay, that's
already in
true.
it, you check?
That's true. That's true.
And the 2.8 times the 8 is the extra water that added
Yes,
after 8
okay.
minutes, plus the 6.7 that was there. So in a total, you have 29.1 liters after 8 minutes. Now, the tank now have a capacity of 50 liters. How long will it take to fill the tank? The tank is being filled with water. The volume of water, V liters in the tank after T minutes is given by the linear equation. That's the volume after T minutes. The maximum volume of the tank is 50 liters. How long will it take to fill the tank? Solution. The maximum volume is 50 liters. Therefore, what does that mean? V max is what?
So V max is equal to 50.
That's a V, right? That's 50 is a V. Consequently, we are trying to solve for, what are we trying to solve for?
For T.
For T. To do so, we must substitute. What must we substitute? To do so, we must substitute. I need a number to come here. 50 into the place of who?
V.
Into the place of Y, into the place of V.
Place of V.
So V.
Yes, V, where Y would be V, yeah.
Right, V is where Y would be. So now, when we do that now, then make, who to make? The subject of the formula?
T.
Make T the subject of the formula because it's T we want. So let us do that. We're going to substitute 50 into the place of V. So what must I write there?
V is equal.
50
No, I wrote it already. V is equal.
50 is equal.
50 is equal to 2.8 times T
Times
plus
2.
6.7. Simple algebra. What is the next move? We're trying to make T the subject of the formula.
Yes. Cancel out 6.7.
By subtracting, right? Cancel out 6.7. Some person might say, bring the 6.7 across. It becomes a minus.
6.7.
What is 50 minus 6.7?
43.3.
43.3.
43.3. And as you all can see in that step, I'm writing a fraction. Why am I writing a fraction?
Because we're going to divide by 2.8 to get T.
Because we're going to divide by 2.8 to get T as the subject. We are all familiar with this algebraic procedure. Dividing by 2.8 to cancel out 2.8. So T is equal to what?
15.46.
15.46. So is there therefore? There's always a little therefore. Right, therefore. The tank will be filled in approximately
15 minutes.
15 minutes, 45 seconds.
15 minutes. 15 minutes, there's still a little space, you know.
45 seconds, I'll give it. 45. 46 seconds, 46 seconds.
15 minutes and 46 seconds. Let's say 16 minutes.
It doesn't matter.
It doesn't matter, it doesn't matter.
It's 2 o'clock.
But if you say 15 minutes, the tank will still have a little space. So best you go above, you check. So let's say 16 minutes about that. Or you can say, you can put the same 15.46, it doesn't matter. So do we understand that question? So you need to do that now for number 11, because number 11 is just like number 10, very similar to number 10. Okay, do we have time to start?
One thing so your class will go so sweet. The time is going. I mean, it's time already.
Yes,
Right.
sir, we have more time.
We still have some time. We still have some time. Don't worry. Let us look at number 11 now. So let's minimize this and let's take a look at number 11. I've prepared something similar for number 11 already. And here it is. Now, number 11 have a slight twist. It's the same application, but there's a slight twist. Let's see how far we can go with it. A variety of tomato plant grows 18 centimeters every week. Please pay attention to this very important point right here. Let me highlight it. Let's talk about it a little bit. Probably we will not really do number 11 as much. We might just analyze it because I don't want to rush. We have enough time. I don't want to rush the brush. We have enough time because I want you all to get it. Because basically, it's not an idea of doing the assignment to submit, you know. You are doing this to create a solid foundation so that, you know, on your higher levels, then you will have a solid foundation for the algebra you are meeting. Every day I'm getting calls, university, and trust me, it's not easy. When you see you in university, especially now you're on your own, okay, that online business there is not going soon, and you might have to do your degree online. So you need to create a solid math foundation. Now, let's talk about that 18 centimeters every week. We know about tomato, we know about plant, we know about growing. Okay, let's include the word grow. Can anybody comment on that very important piece of information?
So that grow there means it's getting taller, it's increasing.
It's increasing. So the grow now, yeah, because I always want to establish that in, you know.
So like the week is like the time frame. Goes 18 centimeters.
The week is the
like,
unit.
So therefore now we already identifying variables. We're already identifying variables, okay? So let's just pause on that little piece of information there before we move on. So now, what can we see? All right, what can we see? Let's just close this. Let's just increase that and let's make some observations. Some very important observations. Some very important observation. Observation number 1. So just voice out what you were saying.
So I was, what are you saying?
Yeah, whatever that's in your mind.
I got something. I don't know if it makes sense. So in my mind,
Trust me,
I'm thinking now.